in this video we want to show you how this Excel file works. This Excel file is useful when you have a data set and you want to know the distribution of this data set. And we use chi-square goodness of fit test to testing that if this data set has the specific distribution. The chi-square goodness of fit test is better when you assume a specific distribution by yourself and then test that if it's following that distribution or not. But in this software you are able to find the distribution as well. So when you open this Excel file for the first time, you may see a yellow ribbon here that asks you to enable the editing of this Excel file. Please enable the editing and then enable the content of this Excel file as well. After that, you will see the user form sheet, raw data sheet, and calculation table, setting, and the pivot. The pivot is used for making the charts in the use form, so you may not use that. You can hide that if you want to. And when you want to find your data set distribution, first go to the raw data, clear the old data, and then copy paste your own data. For example, here I have data in my Excel and I want to copy paste that to see what is the distribution of these data. So it's better to copy paste as value, to not copy the formula. If you have some formula, it's better to not have and just copy paste the raw data. So after you copy paste your data, go to user form and define if your data is discrete or continuous. If your data has no decimal numbers, it's better to choose the discrete type. But if you have a decimal number, it's okay to use continuous. Then you need to choose what is your assumption of the distribution. For example, I assume that this data set has the normal distribution. But if you do not know anything about your data set, you can find the distribution as well. So first, I choose normal distribution. And then class interval is used for the classifying the data into the different classes. So we have the class interval and the class number. So your data set will divide it into 9 classes, and each class has a 6 value interval. You are able to define your own class interval by unchecking this, and then, for example, enter your class by your own if you think the 6 is a lot. But if you want to have automatically calculate the class interval, please check this checkbox. You have not to change the class's number because it has a formula, but if you want to have a different class number, just change the class interval. After that, you need to define the confidence percent. And this percent is used for testing that by the 95% confidence that these data set following the normal distribution. You can change that, for example, to the 98% or 90%, but in the most case we use 95%. And the chi-square is the chi-square of the alpha, which means that the critical percent, which is the 5% when we use 95% confidence, and it's calculated based on the chi-square distribution to test if it's what is the critical value of rejecting or accepting the test. So after you define these numbers, you can press on the run button and then press OK button. So after that, you can see the observed frequency chart alongside with the probability function distribution chart. So you can see the normal distribution is well fitted into this observed data. And you can see the final class's number is 6, which means that after the merging the class number that has less than 5 observed frequency or expected frequency reach into the 6 classes, and the calculated chi-square is the 3.4, which means that your statistical value is 3.4 by using the chi-square goodness of fit test, and the critical chi-square is 7.8. When this value is less than this value, we can say that we can accept this data set following the normal distribution or chosen distribution. But if this value is more than this value, then we have to reject the H0 hypothesis, which is the normal distribution of this data set. But if we do not reject the H0, we say that this distribution is following the chosen distribution, and we can see the parametric estimation of this distribution. So this is how this Excel works. But you need to notice that in the calculation table, we calculate automatically by using the codes in this Excel the observed frequencies which the raw data currently has, and the probability of one data belongs to this class by the chosen distribution, which right now is normal, and the expected frequency, which means that we expect that this amount of frequency be seen if the data set be a normal distribution or the chosen distribution. And in the setting, you can see the different distributions alongside with these with their information. You can add any distribution that you want. For example, I want to add new distribution named AA. I need to define what is the type of this distribution, and I can have two parameters for this distribution. For example, in the F distribution, we have a degree of freedom 1 and the degree of freedom 2 as the two parameters of the F distribution. You need to define how many parameters you have. In this Excel, we cannot have more than two parameters. So, for example, Weibull distribution may have more than two parameters, but here we just use two parameter Weibull. For example, and another thing is, for example, Poisson has one parameter, so you need to leave empty for the second parameter, empty value for the second parameters. After that, you need to estimate the parameters by the point estimation. So, for example, here all these estimations are using the moment estimation method, but you may want to use MLE estimation method, so you are able to change these function by yourself. So for the new distribution, you need to add the function here, but for the other distribution that are defined here, you are able to change any of these function as you need. So for example, here for a Weibull distribution, estimating the alpha parameter is a hard thing to do. We use an iteration function by yourself to find this alpha value, and then by using this alpha value, we use to estimate the beta value. But if you think this estimation of the alpha value of the Weibull is not good for you, you can change that to whatever you wanted. And also, for example, in the beta distribution, we use the moment method to estimate this value. Currently, this value is not valid for this data set. But for example, if you want, you can change that to the MLE, for example, method, or whatever method you want to. So this is how you can change the parameter estimation, or you can add a new distribution. In the another column here is the distribution function. You are able to change the distribution function as well. For example, for a normal distribution, we use Excel normal.dist function. If you want, you can change it to another formula which is developed by yourself. For example, here I use this formula to calculate the distribution function of the uniform in the district data sets. So you can change it to another formula. Also, you need to know that the distribution function need to be in the cumulative mode. So we calculate the cumulative probability function here. And in the one sample, you do not need to do anything with this column, because in the code, first we change this to the minimum value of the classes. For example, here is the 49, so code set this value to the 49 and then get this probability function value, and then after that change that to another class, for example 50, and then get this value and then calculate the probability of these classes by using these probabilities. This method is used for you to enable you to change these calculation. For example, if you want to have another estimation method, or if you want to use another distribution function, or if you want to add new distributions here. So this is how the setting sheets works. In the use form, if you do not know your distribution and you want to find the distribution of your data set, you can choose find distribution, and after, if you run this software, after that the software will calculate each distribution chi-square value and choose the minimum value of chi-square calculated of your data set. So for example, here software think your data set is following the chi-square distribution, and you can see the calculated chi-square is less than the normal. So for example, if I choose Poisson here and then I run this, I can see the calculated chi-square is 4. And if I choose normal distribution and then run, I will see the calculated chi-square is 3.4, which is less than Poisson. So the normal is better, has a better fit on your data. And if you choose the chi-square distribution and then run the software, you will see the calculated chi-square is 2.9, which is less than normal as well. So the distribution of this data set is chi-square, has a best fit for this data set. And if you want to have a PDF file of your analyze, you can press the PDF button and then choose the desktop or any folder you want to save the PDF file, and then choose a name. For example, change the report to whatever you wanted, and then press OK button. After that, a PDF file is generated, and if you go to the desktop, you can see your report PDF file as well. So this is how this Excel file works. You can test that if your data set is following the chosen distribution, or you can find your data set distribution as well. Thanks for watching and goodbye. In order to watch more training videos, please subscribe to our YouTube channel, Deyako Ltd. And if you want to see our products, please visit our website, deyako.co.uk.